Hi there. In this quick video we'll be taking a look at a PeakTech 2710 RCD tester. And this is its box. Let's see what we have inside. Okay, cable. Wait a second. Okay. I was actually wondering how will this connect to your sockets. Well, it connects via a standard cable that we also have in computers, for example, or printers, or who knows what. Makes sense. So basically, this is not to power the device. This is just to make an electrical connection between the device and the socket that you are testing, basically. Although you are testing the RCD that is connected to that particular socket, but details. And a lot of batteries. Okay. Bunch of batteries. I wonder. We might have a lot of them in here, so I might be getting a bit ahead of myself, but two things that normally I don't see in other devices: cable like this and 6 batteries. Okay. Blue is rubber. Obviously, buttons are rubber. Okay, we have a dial in here. Yeah, I need to check that out a bit later. Let me put in the batteries. So, be back in a second. Ooh, a trap. I opened those two and I was thinking, hey, why is this not coming out? Then I realized, wait a second. This is actually the whole back of it. So obviously also bottom ones need to be undone. Okay, screws undone. This is the back of it. 6 batteries and the cable. It might be weird to some of you which are familiar with such devices, that I'm surprised, but this is what I had until now. So yeah. And I will tell you why this is not enough, at least for me, at this particular moment. But that will happen after I draw a diagram, because I need to explain my weird situation that actually might not even be that weird, but I think a lot of electricians actually, I don't know, don't properly, sadly, understand some things. But yeah, that's for a later time for me to explain to you. Now let me put this and get back to you. So yeah, while I put the cover back, I will try to explain. So 6 batteries in here. Be careful about the polarity, obviously. This house has a 30 milliamp tripping current RCD. That's for the whole house. When we installed in the bathtub with a pump in it, so basically the type that massages you, in its instruction said, I don't know, I think 15 milliamp RCD. So obviously couldn't put one of those for the whole house, could I? And at that point I added one special for the bathroom for that tripping current that was required. Then I tested it with this little guy. Well, surprise, the 30 milliamp tripped and the 10 milliamp did not trip. Ain't that fishy? To make sure that the 10 milliamp, the 15, not 10, sorry, milliamp, or is it actually a 10 milliamp? I will write on video and clarify that. that one is actually good. I briefly removed from the circuit the main 30 milliamp, and the 10 or 15 milliamp actually tripped, so that one is also good. Then I contacted, I think, Eaton and Schneider, because one is Eaton, one is Schneider, but tried with other brands, same behavior, and told them, hey, I have two, and the lower value one that is more sensitive is not actually tripping before the main one. They were like, we don't know. So my only logic would be that there's a difference in tripping time between the two, and the 30 milliamp one actually has a shorter tripping time, and it actually manages to trip before the other one, because this thingy doesn't know to test at less than that. So what I want to do with this, test at 20 milliamp. So the 30 milliamp should not trip, and then we should only see the 10 or 15 milliamp trip, if it makes sense to you. A bit of weirdness. And I also asked a bunch of electricians, and all of them were, but why do you have 30 milliamp on your whole house? That's too low. You should have, I don't know, 300 milliamp or 150 milliamp. I'm not sure which is the next value. And I was saying, but it's not tripping by itself. I have appliances that I keep in good working order. I don't have leakage currents willy-nilly adding more than 30 milliamp to trip my my RCD. So I have a low value RCD and everything is working absolutely perfectly. But all the electricians that I asked, obviously there are many more that know what they are talking about, but the ones that I asked were continuing to give the same answer. But yeah, but you should put a bigger one. But no, because the lower one is actually doing its thing, but it's a bit of weirdness. It's actually tripping faster than the lower value, but in case I don't exceed its value, I expect the lower one to actually trip first. Anyway, this will finally help me. It was actually on. It was actually on. This will actually help me test that weirdness and see who is tripping and why is tripping faster. That was anticlimactic. A corner was caught under the plastic. What do I unplug to plug this in? Hopefully I don't do anything stupid. This is a mains rated device, so maybe it should be better to read the manual, but you know me, where's the fun in that? So mains is already on. Maybe I should have put this thing on first. Wait a second, mains off, mains off. Let's see, this thing on first. 0 volts, okay, mains on. Okay. That's actually cool. Do we have a backlight in here? Yeah, we do have a backlight in here. Nice color. Let me shut off the light a little bit. Yeah, it's easy to see. I do have reflections around here, so sorry about that. What I see is more like this. Voltage quite stable. In the morning is way less. We are at 215 volts because there are some big companies around and they draw all the juice from the network, it seems. But yeah, at this hour it seems it's all good. Honestly, I'm afraid to do anything without reading the manual, so I think this is as far as I will go without reading. We saw the voltage and yeah. Let's take a look at the manual, and in here we have the calibration page. Calibration done at 25 degrees, which makes sense. Keep that in here, and yeah, I will be taking a look at the manual and get back to you in a moment. Okay, as we always expect, at the middle English starts in PeakTech manuals. If the voltage is above 230, plus minus 10%, obviously. Do not use the device. So if it shows 400 volts, your wiring is wrong, disconnect it immediately. This is not designed to test for the presence of voltage. There are other devices basically specifically made for that. I will link a video with a PeakTech, such a PeakTech device in the description. If it shows 50 volts, do not try to continue with the test. You have another fault in your circuit. Obviously, carry the measurements in compliance with all safety regulations. Service by qualified personnel, yep. Don't make changes to the meter, yep. And do not let your children play with it. This is mains connected. It's not for children, obviously. My girls do play with, where is it? With the PeakTech tool. And I will show you what PeakTech tool they are allowed to play with. This is the PeakTech tool they are allowed to play with. It's a magnetic field detector. So, yeah, they can play with this little guy. They like it that they can find magnets in their toys. This is not a mains connected tool. So yeah, that's that. And yeah, let me just give power again to this. And this is a voltage detector. Completely different thing. This has not the doesn't have the purpose of detecting your voltages. So you can see here display, obviously 0 180. We'll get to that in a moment. Test button, the switch, and that I need to check in the manual. I didn't actually understand. Range button, power jack, yep, the one where we plugged in the cable, pot hook, and battery cover. Ah, yeah, this thingy, you can actually hook something onto it. For me, that's not going to be used. So now I realize something. Let's give this thingy power. And wait a second, let me see what happens when I start this. Okay. Okay, good. These two things is flickering. You can see them there. Let me bring back the light. Well, that means that I'm plugged reversed into the socket. So let's do this again. I wasn't expecting this particular socket that I'm plugging into to be reversed, because normally I have phase on the right side of sockets, but this is an extension, so yeah, it seems it doesn't keep that rule, because I have the text on the extension actually right side up. Maybe I plugged it backwards into the socket where it's connected lower. If you make some static, you can see interesting stuff on the LCD. Sorry, got carried away. So now we are connected properly. They are not flickering anymore, PN and PL. We have ground in here, which is great. It's telling us that this is not really meant to detect other problems in your circuit. This is for RCDs. You can see here plus minus 10% and at 50 Hertz the frequency. Don't use higher than 300 volts. This is info on how to test an RCD, how to select the RCD sensibility. You select it, I think we can go here and you can see there the values. So now I realized something. This is what I have for that bathroom, so it wasn't 15. This is what I have for the whole house. And the electricians what were not recommending for the whole house 100 were actually recommending 300. I don't know why. But anyway, doesn't really matter. Let's get out of this. I don't want to trip something at this time. It also tells us in the manual that when using this, after testing you will be left without power on that socket, so be careful what you have connected to that socket, especially if you are testing, I don't know, in a hospital or somewhere, and you do not want to let particular devices without electricity. So yeah, this I don't think I have this situation where I have selective, so that requires for the RCDs at the furthest point of the installation to trip first. I don't have that situation, at least I don't think, from what I understand. This we will test with both variants, depends on where it starts, if it's up above the line it's positive, or below the line, depends where it starts to test the RCD itself. Type of test, either okay or in time. Okay, so okay, what's this? Okay, not really sure yet. We'll see about that. Get out of that mode. Auto measurement function, so here it does a whole program and a whole series of tests. Measurement results, the characteristics of the unit itself, and the specifications. Trip times at 0.5x we have this. I think that's basically, if we put 10 milliamps, we put how much the fuse, the RCD actually has, and we set it at 5, that means it trips with 5 times that value. 0.5 it actually tests with half of that. Maybe I need to try and understand this a little bit better. I'm not 100% sure I got it right. How to replace the batteries? Obviously disconnect it from mains and only then open your cover and put same types of batteries in there. And yeah, that's about it. Just want to quickly show you, I'm connecting to a socket that does not have a ground, and I know for a fact that this has phase on the right, so I'm plugging this accordingly. I'm not going to let it a lot of time connected in here. It will show us 50 volts. You can see it right there, and you cannot test in this mode obviously because you don't have ground, and it shows us there's no ground connected. I know it's not the point of the video, but couldn't help myself. Checked the extension cord and it's literally wired wrong. I have no clue why. It's plugged in normally. When you plug it in, right should be phase and this should be neutral. Well, it's plugged like this into a socket where I checked and we have phase on this pin, and when it ends up in here we have it on the left, not on the right. So yeah, and it's obviously cutting the wrong one, so I actually still have power when this is off. That I do not like at all. What did I do here? I think I'm going to rotate it in the socket to basically have it the wrong way around, but that's life. But at least it will completely cut power when it's off. That's no bueno at all. And I discovered something really interesting. So these extensions are made willy-nilly, however they choose. You can hopefully see the text. Let me give you a bit of light in there. So this should be right. No power. No power. So this one is also, it's a different brand, different model, still wired wrong, but at least no power. So that means that it's wired wrong only in here, but up to the switch it's wired correctly internally. Yeah, never had a clue about this. Okay, so as they say, ignorance is a bliss. Now my OCD is making me go and check all the extension cords in the house and see if they are wired properly by the manufacturers. Doesn't matter that much, because things like this, for example, you basically don't really have that much of a clue how you plug it in, but yeah, still I want to have phase on the right and neutral on the left. Okay, so initially I wanted to draw a circuit that reproduces real life much more accurate, but I realized it was becoming too complicated and many people might just not understand it. So simplified it a lot. Let's say this is our voltage source, 230 volts, 50 hertz. This is the tester itself. This is not a switch, it's the tester. And these are the two RCDs, the one inside the house and the one outside the house. And although this is lower value, 10 milliamps, we are actually tripping this one first, the 30 milliamps one, and I'm expecting this is happening because this has a faster reaction time than this one, and we are testing with a current that's enough to trip it. If the current were lower, this one should actually trip because this one is not reacting, so it's the only one left that could react. But let's continue with our video and see if I'm right or not about this. We are at the internal electrical panel. This is what we want to trip. As you can see, 0.01 amps. This is for something else. This is also for something else. And this shows us that we have mains coming in from outside. So we want this to trip and this to remain on. If this is off, it means we tripped the outside main one and we don't want that. Let me just show you first with the tester from Lidl what happens. And it's inserted, and as you can see, we are in this case, the wiring is correct and we can test RCD. I will film the fuse outside when I press this button. So at this point I'm getting ready to press the button and we don't want that light to be off. And it's off. So the outside one cut, not the inside one. As you can see, this did not trigger. Just in case anybody is not sure, not triggered. And we don't have power, so I need to reset the outside one and get back to you. We are back. I connected the PeakTech. Let's set it. So this will test at 5 milliamps actually. N means actually normal and S was selective. I realized that. I'm testing with normal. And yeah, range, that's good. Let's see if it triggers at this. I'm expecting it not to trigger. So yeah, I'm not sure. I think I will film this and then show you what happened on the panel. Or maybe do both. If that triggers, then I can set it and yeah, I will show you what happens in both cases when I film this and when I film the fuse. Let's test. Basically, nothing happened. Let's see in here. I think I need to press it. And it tripped. And this is the time. Let me show you the fuse. And we are at the fuse. You can see it right there tripped. Let's reset it. So it tripped this one, not the main one from outside, which is exactly what I wanted to see. This one working at 10 milliamps. That's awesome to see. Let's see something else. If we change this, will the time change? Could change, but we don't know yet. Let's see. Nope, did not change in case of this particular fuse. For good measure, let's just test once again to trip this one and see if we get exactly the same time. Yeah, exactly the same time. Perfect. And now, let's go, come on, to 30 milliamps. I think I will leave this in here And let's see what trips. And we will also see the time. The main one tripped, and as you can see, it has a much quicker reaction time compared to this one. That is why it's tripping first. If there was any question about it, obviously not tripped and tripped, because the other one has a much quicker reaction time compared to this one. So this has lower tripping current but higher reaction time. And I'm extremely surprised that Eaton and also Schneider, the manufacturer of the outside one, did not know to tell me this. This is the outside one, as you can see, clearly tripped. So yeah, and this is its value. Weirdly enough, they didn't know that it has a different tripping time, completely different. And now another test. I'm back at 10 milliamps. I'm trying to also trip the internal one. Let's see, times 2. So we are testing at 20 milliamps actually at the moment. Oh, and this thing basically timed out, I think. Okay, back at this. Light on. So it does have a timeout. We just learned that. 10 milliamps times 2, 20 milliamps. The outside one shouldn't be tripping, but the inside one maybe trips faster at a bit higher current. Let's see. Yep, it trips faster, but still much slower than the outside one. If there was any question about it. So even at 20 milliamps, this one is still doing its job. And the outside one, it's below the 30 milliamps and it's not tripping. And I also think I understood what this wants to be doing, not auto. I think this will actually test, although we still have range. You know what, I'm not really sure. But I'm expecting it to show us at what current it trips. So it will raise slowly the current and tell me where it trips. Let me see. So it trips at 7 milliamps. This is really nice. It trips a bit before. It's safer before than after. You know what I mean? Okay, moved into a different socket and let's test normal. Range should be 30 milliamps. And 30 I said. Now let's do the test only for the outside one, because this is not protected. This is not in the bottom, this socket. So let's see what happens here. So by raising it, it tripped at 24. And maybe now I can understand also this button. Let me show you why. So let me try and see what happens. And why did nothing trip yet? Okay. Okay. So it's after that timer, it starts to count up. But if we put bigger values directly from the start, like we put 100, it actually starts to count from 40 or 42, whatever it was. So yeah. And now that we all know that I'm actually right, I've set up this little circuit here with two fuses. One that can take 1 amp. This one can take 2 amps. But this I set it up to be faster to react than this one. And obviously with this circuit in here, it has a lot of power, so it's able to pop them without any issue. So I'm going to show you that, yeah, basically the one that can take a higher current trips and breaks and pops, because it has a lower reaction time. So let's see, are we running this? I think we were actually running it. And it's popped. And exactly this is what's happening in my situation. we are popping the one that in theory should react to, it goes to yellow and then pops, should react to a higher current, because we are testing with a high current and it has a lower reaction time, and thus this one doesn't have time to react unless we are testing with a lower current. So yeah, makes sense now, and I seem to be right. I was right about this, and it's really weird to me that trained professionals, representatives of two big companies, were unable to tell me that it's all about reaction time. So yeah, again, this is not a proper diagram of the circuit. This is not how it should look like, but I tried to simplify as much as possible to give at the end of the video a clear visual representation of what's actually happening when we are testing with more than 30 milliamps. And from my side, that's about it for this video. For me, now everything is crystal clear, everything is working as intended. It's just a difference in, I don't know, activation time or reaction time of those RCDs, which is probably by design. I don't expect to be anything else there. So yeah, that's about it for this video. Thank you very much, PeakTech, for sending this in. I finally understood what's happening here and cleared a few things up. This is quite easy to operate once you understand exactly what it does and what results it can give you and how it works. Quite a nice tool and quite useful tool. And honestly, if you are watching this video and you don't have RCDs in your house, install them. It's basically one of them occupies the space of two standard fuses. I don't believe you have your panels that occupied that you cannot find a bit of room for one of those. If you cannot install dedicated ones, at least have one for the whole house. It literally can save your life. So yeah, hope this video helps you, in which case please give it a like, check out my other videos, and as always, see you in the next one. Bye.